This is the first tutorial on limits. I want to go through and make sure that you're okay with the notation and what it is that you're actually finding. So here's how I'm starting this. If you consider this function right here, x squared, what I have is, as at 3, I have the point blotted out. Because when we're dealing with limits, we're not going to be interested in what happens at the point under discussion. We're only interested in what happens around it. So if you look at what I've done here, if I take this point, which is the x coordinate of some point that's less than 3, f of that point would be given by this blue line, and then the red line would tell me exactly where it is. So this is f of x, and the red arrow is pointed to the actual range value. So in this case, the domain value looks like it's like over here it says the domain value for a is 2.67, and the range value would be up here, given by I, the length of that line, would be 7.14. And you'll notice as I move the point closer and closer and closer to 3, I don't want to get to 3 because if I get to 3, I don't know what's happening behind that box. But as I move the point closer and closer to 3, as the blue point gets closer to 3, the tip of the red arrow is going to be getting closer and closer to 9, which shouldn't really be a surprise. I mean, we understand the function x squared. So again, this would be as I'm approaching 3 on the x-axis, due to the function, on the y-axis, my corresponding points will be approaching 9. Now, if I go and flip over past it, I can also come towards 3 from the other way. So here I'd be coming at 3 from the right. And also you can see as my x-coordinates come down on top of 3, my y-coordinate is coming down on top of 9 rather. So you can see, and you can look at the coordinates here. The x-coordinate, well, look at the coordinates right here for point B. That would be 3.26 is the x-coordinate, 10.64 is the y-coordinate. Now notice as I come down, the x-coordinates are now like 3.1, 3.14, 3.13. The y-coordinates are rapidly coming down on top of 9. And I'm at 3.02 and it's 9.13, but you can see pictorially exactly what's going on. Okay, so, and you'll notice I'm not allowed to get to, I don't want to ever get to 3. If I get to 3, I don't know what's happening behind that little black box. So I put the little black box in here because we're not interested in what happens at 3. Maybe that function's defined, maybe it's not defined. We don't have any way to know. Okay, so let's look at what I've done now is this. Let me get this out of the way. Click on this. Here's a picture of what we just had, and here's going to be some notations of how we're going to write things. So we're going to say this. When the point was here, and we were approaching 3 from that side, what we say is this. The limit as x approaches 3 from the left. In other words, all the values that x is less than 3, are less than 3 of the function f of x. So in this case we know our function is equal to x squared, and we can see from this picture as x approaches 3 from the left, the function is heading up toward 9, or you could say the y values are going to be heading up towards 9. So we would say in this case that the limit as x approaches 3 from the left is definitely 9. And then if we were to take this blue line, this is a solid picture, I can't do it anymore, but if we take the blue line and we were to put it over here as you saw, and we approached 3 from the left, from the right, we would say the limit as x approaches 3 from the right of x squared. And then we go to our picture and we'd see any x value that I pick on this side would be a corresponding function value up here, and that would be coming down toward the black box, which would be coming down towards 9. So we would also say that the limit as x approaches 3 from the right of x squared is equal to 9. Since these two things are the same, we would say it this way. The limit as x approaches 3, in general, not from the right, not from the left, just from both sides, of x squared does equal to 9. So basically we can say that a limit exists in general if the right-hand limit and the left-hand limit both exist. So in general we'd say this. The limit as x approaches some number k is 3 in this case, of some function f of x, which in this case is x squared, is equal to a particular value L if we can say this: the limit as x approaches k from the right of f of x equals L, and the limit as x approaches k from the left of f of x is equal to L. So as long as I come at k from both sides and I approach the same number, then I say that the limit does indeed exist. Now there's going to be a lot of other examples in tutorials to come that show you when it doesn't exist and all kinds of different ways to evaluate these, but this is the first thing that we're talking about to get you your feet wet with regards to the notation, how it's written, and what I mean when I say limit as x approaches. X approaches something on the y-axis, x approaches something on the x-axis, and then you're looking to see on the y-axis what the corresponding x values are going toward. And that's the simple way to look at it. All right, so more to come.